In my video, How Olive Oil Makes You Fat, I pointed to this study where researchers in the Mediterranean pointed out that people in the Mediterranean who eat more olive oil are indeed fatter, but it's not because of the olive oil you see. It's because they have excessive positive energy balance, which is to say that they are overeating, they are hyperphagic. Now, we've seen hyperphagic before. Grizzly bears have a whole hyperphagic season starting in August, going into November, and they get there by eating ants starting around the beginning of July. Interestingly, though, they don't eat many ants in May. In May, the bear cubs are like, "Hey, mama, should we eat these ants?" Mama's like, "Are you crazy? Swimsuit season's coming up. Those things are full of mufa." But why does mufa cause hyperphagia? This is on the left is anandamide, also known as AEA. So this is what's called an endogenous cannabinoid. On the right there is THC. That is, of course, the main drug in marijuana that gets you high. So our body makes a chemical which is almost exactly the same thing as THC. If you look at actual walking around obese humans, they have elevated levels of AEA. We know this is causal in obesity because a drug called rimonabant actually caused pretty dramatic weight loss. Rimonabant blocks the cannabinoid receptor and it blocks the activity of AEA. And you can see that over a year it caused a 10-pound weight loss in people given a rimonabant, and it dropped their waist circumference by almost 1.5 inches. And all this is doing is it's blocking the effects of that AEA or that anandamide. Furthermore, if you take AEA and you inject it into the intestine of rats, the rats get the munchies. So these rats have actually just had a meal, and then after the meal, they either leave them with free choice feed, that's the white bars. So you can see after 60 minutes, they eat this much. After 120 minutes, they eat this much. After 240 minutes, which is 4 hours, they eat this much. But if you take some AEA and you inject it into their intestine, the rats eat significantly more. So where does AEA come from? Well, it's actually made from linoleic acid ultimately. Linoleic acid is converted to arachidonic acid via the enzymes delta-6 desaturase and delta-5 desaturase. Then via these other enzymes in the plasma membrane, the arachidonic acid has an ethanolamide added to it and is released as anandamide. AEA. The activity levels of these enzymes, delta-6 and delta-5 desaturase, are increased by oleic acid, and I showed the evidence for that in my video, How Olive Oil Makes You Fat, if you want to go back and check that out. There's an enzyme called FAAH, and what that does is it breaks the anandamide back down into arachidonic acid and ethanolamide. And so if you have high FAH activity, you'll have low AEA and you won't have the munchies. So this is in humans, and what you can see is that people with different versions of the FAAH genotype, if you have a less active version, this AA version here, you're about 2 BMI points higher than if you have a different version of that gene. And so you can see in the real world, the activity of FAAH is absolutely crucial in controlling obesity. And so back to our map here. So oleic acid is activating D6D and D5D to convert this linoleic acid to anandamide, and then FAAH breaks it back down to arachidonic acid and ethanolamine, and you can see the AEA. AEA has some very interesting metabolic actions. This is in mice where the FAAH gene has been deleted. And so these mice don't have FAAH, the enzyme that breaks down AEA. And so that allows AEA to build up. What you can see is that they actually have decreased energy expenditure. AEA is directly lowering their metabolic rate. And you can see this T3 and T4, those are thyroid hormones. So if you don't have the enzyme FAAH, which breaks down AEA and AEA levels rise, you will have lowered thyroid hormones and you'll have a low metabolic rate. This is another test from that same study just to show that this really is caused by AEA. They took normal mice who have an FAAH gene and they injected them with AEA. And indeed, again, you see lowered energy expenditure. You see lower metabolic rate because you're getting injected with this cannabinoid. So not only is it making you hungry, is it giving you the munchies, it's also lowering your metabolic rate. And what you can see is that it's also activating something called PPAR gamma. And I also talked about PPAR gamma in the How Olive Oil Makes You Fat video. It's not something that you want to be activating all the time. And these are all PPAR gamma target genes. And so what they showed is that AEA, one of the downstream effects of it is to activate PPAR gamma. And I showed in How Olive Oil Makes You Fat, a pharmaceutical drug that activates PPAR gamma causes weight gain. In mice with a deleted FAAH gene, so high AEA levels again, they also showed they are slightly insulin resistant and they have very high triglycerides. That's what makes this Natambi paper so interesting, because they showed that palmitoleic and oleic acid, so those are both monounsaturated fats that are at the heart of the Mediterranean diet. That's what olive oil's made of. That's what we're supposed to be eating. And those two things inhibit FAAH activity in vitro at low micromolar concentrations, and that's not very much. They gave these mice a certain quote-unquote high-fat diet, and we'll get to what the composition of that was, but what happens is, and this is in their livers, you see this huge increase in oleic acid in their liver. So it goes from maybe 10 up to about 120. So that is, so you see this 12-fold increase in oleic acid in the liver. And when oleic acid goes up, FAAH activity goes down and AEA goes up, right? And that is all caused by this oleic acid, which, like I say, they showed that the oleic acid directly inhibits the enzyme FAAH. And so we can go back to our map and we can say, look, oleic acid is acting on two ends of the spectrum. It is increasing delta 5 desaturase and delta 6 desaturase, which creates more arachidonic acid, which allows the cells to make more anandamide, more AEA, and at the same time, the oleic acid is blocking the enzyme that allows us to break AEA back into arachidonic acid and ethanolamine. And this is a study of circulating metabolites in obesity. They say 43 metabolites are positively associated with percentage of body fat. So the more body fat you have, the more linoleic acid and oleic acid that you have. And again, the linoleic acid is the starting point that AEA is made from, and oleic acid is the thing that drives the enzymes that turn the linoleic acid into the arachidonic acid and, of course, block FAAH. So it's not terribly surprising that in obesity you see high levels of those two fats. So is there anything we can do about this? And I'm going to briefly talk about what we can do about this. And then for the real nerds out there, I'm going to look back at that paper that shows that olive oil inhibits FAAH activity, because the authors argue that dietary oleic acid is fine. Don't worry about that. Only worry about it if you're making it via your enzymes such as SCD1 internally, but it's fine to eat all the olive oil you want, right? And they're saying that because, of course, saying something as crazy as olive oil makes you fat is not a good career move if you're in the nutrition industry. Anyway, what can you do? I've got images here of two of the best things to fight the production and the effects of AEA, which is capsaicin, which is the chemical that's in hot chili peppers and hot sauce, of course, and long-chain marine polyunsaturated fat. First, let's hit the polyunsaturated fats. So this is actually the study that I took that map of the D6D and the linoleic acid becoming arachidonic acid. That's also an interesting study, but it doesn't have anything to do with oleic acid. But what you see here, what they did was they increased the percentage of linoleic acid, right? So that's the starting point for arachidonic acid in AEA, and you can see that AEA levels go up significantly if you have more linoleic acid. But then what they also showed is that if you supplement that same diet that's now 8% linoleic acid instead of 1% linoleic acid with DHA and EPA, so those are long-chain PUFA from fish oil, what it does is it actually competes with those enzymes D6D and D5D for the conversion of linoleic acid to arachidonic acid, and AEA goes back down, right? And so you can go out and get yourself some pickled herrings or some kippered herrings or some creamed herrings. You can also eat other kinds of fish if herring isn't your thing. And that might help you prevent that buildup of AEA. Another thing that you can do, like I say, is capsaicin. If you like hot sauce, so this is in those rats again. And on this side, we're injecting rats with Win2 is another cannabinoid. It's a synthetic cannabinoid. And you can see that the Win2 made the rats overeat. It gave the rats the munchies. But if they also injected capsaicin, that actually blocks the effects of the Win2, because capsaicin actually seems to block the cannabinoid receptor. And so hot sauce, capsaicin is another way to block the disastrous effects of the cannabinoid AEA on obesity. Now, I want to think about what their statements on dietary monounsaturated fat. Does it matter if the MUFA comes from your enzymes or from your diet in producing this rise in AEA? And what they say is a high-fat diet rich in monounsaturated fat or feeding mice pure oleic acid fail to inhibit hepatic FAAH activity. And if you don't inhibit FAAH, then you won't have the rise in AEA caused by olive oil. And they furthermore say, we conclude that MUFA is generated via SCD1. Now that's the enzyme that you have that allows you to make oleic acid in your cells, but not diet-derived MUFAs. Function as endogenous FAAH inhibitors, which causes insulin resistance ultimately. So this is a bit of cognitive dissonance, I would argue, with jokes. This paper's full of jokes. And the reason it's cognitive dissonance is, how does the enzyme know where the monounsaturated fat came from, right? How does FAAH, as it's being inhibited, think, oh, this is dietary MUFA, I'll just keep doing my job, versus it came from an enzyme, right? It doesn't know and it can't know, and that's where the cognitive dissonance comes from. What they did was they fed the mice a low MUFA diet. And so this diet is based on vegetable shortening, partially hydrogenated vegetable shortening. So this is the composition of the, quote, low MUFA diet. You can see that it's about 45% saturated, it's about 24% trans MUFA, and it's about 24% cis MUFA, and it's about 7% polyunsaturated fat. And this diet made a lot of AEA, and that first study that I showed you had 8% of calories as linoleic acid, and that produced a lot of AEA, right? The ones where they reversed it with fish oil. This one is about, in this diet, 60% of the calories are from fat, and 7% of that fat is linoleic acid. And so this diet is only about 4% PUFA, so it's about half the PUFA of that diet that I showed you with the fish oil that didn't have a lot of oleic acid in it. This one has a lot more oleic acid and only half the PUFA, and it also caused this massive increase in AEA level. You can see here down to the bottom, oleic acid, this is the main trans fat that's in margarine, and a trans isomer of oleic acid. So oleic acid is MUFA. And so really you can add these two things together. This diet is really 48% MUFA. That's the low MUFA diet. And the reason they used oleic acid is oleic acid massively stimulates the enzyme SCD1. And so that particular type of MUFA causes a massive increase in your body's production of oleic acid monounsaturated fat. And so meanwhile, the high MUFA diet actually has 36% of MUFA, and it has 32% of PUFA. So you can see there's a lot more PUFA this one, if you think that linoleic acid is the main thing driving AEA production, you would think that this diet with higher linoleic acid content should have way more AEA, but in fact, it's the one with more MUFA, quote unquote, the low MUFA diet. It gets very confusing, right? Because they don't really want to tell you the truth. And saturated fat content is 32%, right? And so now your brain is like exploding. And so the first joke that they're using is a semantic joke, right? Trans fat is MUFA, and they're trying to pretend that it isn't because, you know, they want to change the results, right? Right. And so now what they say is a high fat diet with similar fat content, but a much higher monounsaturated fat composition failed to suppress hepatic FAAH activity or increase AEA content. And where can we find this data? Oh, it's in figure S5. Oh, right. The S5 means supplemental figure 5. So they don't really want you to look at this graph, right? Because they're going to hide it over in the supplementals. And that means you have to click on the link and you have to download this whole other thing. And anyway, and most people don't look at the supplemental. They just take the author's word at it. And so that's the second joke, is we're going to put the data in the supplemental. And so here's the actual data, okay? So the gray, these are the mice with the quote-unquote high MUFA diet, which is 36%, which is a pretty low MUFA diet in terms of most mouse diets, or even in terms of most human diets. You know, you look at the AEA and you're like, yeah, it's about the same. And you look at the FAAH and you're like, yeah, it's about the same. And meanwhile, this one, which has been seeded with this trans fat, which, by the way, the trans fat thing is never mentioned in the rest of the paper. You have to look at the materials and methods to realize, you know, the jokes that are being told. And anyway, so this one has this big outsized response on AEA because the trans fat activates SCD1 and it has these disastrous effects. And so they stick that in the middle and they say this one's lower in MUFA, which again is it's a joke. And so what I did is I just rearranged them and I put the white next to the gray. And when you put the white next to the gray, you can see that in fact, the 36% MUFA diet, not that high in MUFA, indeed increases AEA, and it does indeed decrease FAAH activity. It probably, you know, fails to reach statistical significance because they don't use enough mice. Furthermore, this diet with the trans fat massively increases AEA. So comparatively, it looks kind of minimal. And so the third joke is they're using these visual tricks by separating the white from the light gray bars. And so then they say, oh, mice gavaged daily with 300 milligrams oleic acid does not affect FAAH activity. Gavage means they basically take some oleic acid in a syringe and they just squirt it into their mouth and they have to eat it. And so again, you see where's that? And so this is pure oleic acid. This is triolein. And where is that data? Oh, it's in the supplemental again, right? Of course it is. And so then you see, well, after 8 hours, you're like, oh, well, that kind of actually looks like it did decrease FAAH activity. Looks to me like triolein acutely suppresses FAAH activity, but they say this does not reach statistical significance. And so they're using a statistical joke. And it's interesting because you have to wonder how many different dosages did they try and how many times did they run that experiment before they could say this definitely doesn't decrease FAAH activity. And then the big question at the end is, if you really want to show that dietary oleic acid doesn't decrease FAAH activity, why don't you just feed them olive oil instead of this other, diet that you found that only has 36% oleic acid in it? And so that's the final joke, right? Is a joke of omission. And so this is another study, actually. And so they took these mice and they actually fed them the exact same diet from the same manufacturer as in the previous paper when they said this is the 36% MUFA diet, right? And the previous paper said the high MUFA diet, the 36% MUFA diet, does not increase FAAH activity. And so you can see on this graph, this is plasma AEA. And you can see that absolutely, in this case, after 6 weeks and at 36 weeks, although weirdly not at 22 weeks, and I don't know what happened there, but clearly at 6 weeks and clearly at 36 weeks, the very same diet that the previous author said does not increase AEA, clearly does increase AEA. And this quote down here, of course, is from that first paper. A high-fat diet rich in MUFA failed to inhibit hepatic FAAH activity. This paper shows that's clearly not true. This is just another paper that I found. This is a little higher in MUFA. I couldn't find any studies where they gave any mice or rats or anything else a truly high MUFA diet to see what happens with AEA. But in this case, it's a little higher. It's 43% MUFA. And they looked at the hypothalamus. And you can see, and this is AEA levels, and you can see they go from about 28 to about 38 on this, quote, high MUFA diet. And so this, so 43% MUFA with quite a bit of PUFA as well, made a pretty big jump in AEA production. And so the next video, we're going to talk about Predimed. Oh boy, are we going to talk about Predimed. That study is like, it's like a train wreck if every car on the train was carrying a dumpster fire. I mean, what a disastrous study for olive oil. I don't know how you could have a worse result. This Predimed has been spun into the study that proves that the Mediterranean diet is the best thing on earth. It's a disaster. So come back for that. I'm Brad Marshall, author of the blog fireinaBottle.net. You can join the discussion on Reddit at r/saturatedfat. Follow me on Twitter at @fire_bottle or on Instagram fire_in a bottle. Thanks for watching.